Welcome to the next lesson. In this lesson, we're going to be looking at acids and bases. The learning outcome for this comes from the study design, and you can see it's to look at the Bronsted-Lowry theory of acids and bases, including polyprotic acids, amphiprotic acid species, and writing ionic equations. We're going to just be focusing on polyprotic acids, amphiprotic acids, and what an acid base is. So acids and bases, they're collections of chemicals. We find them in everyday life, and they have a number of properties. And so these are some of the properties that define acids, and these are some of the properties that define bases. You can read those in your own time. But you can see that clearly acids taste sour, they react with bases and have a low pH as some of the key features, and bases have a high pH and they taste bitter. So an acid is defined as a substance which produces or donates hydrogen ions in water. So they're known as proton donators or proton donors, whereas a base dissociates or breaks up and they make hydroxides. They're known as proton acceptors. You can see here, if we add acid to water, we have mostly protons, these hydrogen atoms here, or hydrogen ions, sorry, and we have, when a base is added to water, we have mostly hydroxide ions. Here's your hydroxide, and here is your hydrogen ions. You can see this again. Hydrochloric acid is a type of acid. It's a strong acid. You place it in water, it will break up into predominantly hydrogen ions. When you place sodium hydroxide in water, it breaks up into predominantly hydroxide ions. It is therefore a base. So acids, as I mentioned, they're proton donors. So here is an example. Here's an acid, hydrochloric acid. Its proton, or the hydrogen atom from this molecule, this compound here, will donate to the water. The water here can be seen as a base. That hydrogen atom will go over to that water molecule, and that water molecule will become this H3O. This H3O can donate a proton itself, so now we call it an acid as well. But here is the acid to begin with. Donates its proton to water. Water becomes H3O, and the Cl becomes Cl-. We mentioned before that bases are proton acceptors. So here's an example of a base. The proton is donated, or one hydrogen atom is donated from water to the nitrogen atom here to make ammonium. And we can see that is now become an acid because it has the ability to donate a proton. So whenever we have an acid, it will donate a proton and it will form what's called their conjugate base. Here are a number of acids. They lose a proton and become what's called a conjugate base, meaning they are the base form. They can now accept a proton. Similarly, over here, we've got our bases, a selection of bases. They accept, or a proton is added to them, and they become a conjugate acid because they can now donate or lose a proton, meaning they are a conjugate acid. Here's an example of such. Hydrochloric acid is placed in water. It breaks up into chlorine atoms, and the hydrogen atom will move from the hydrochloric acid onto water to become H3O+. This is just purely showing the conjugate base over here and the conjugate acid. Certain acids, they can actually donate or accept protons, depending on what they react with. This means they are known as amphiprotic. If something can donate a proton, so over here, this substance is donating or losing a proton when it goes this way, become HPO4 2- from H2PO4, and similarly, it can gain a proton, become H3PO4 or phosphoric acid. So all these compounds can, in the middle here, can either accept a proton, so like a base, or they could donate a proton like an acid. They're known as amphiprotic. When we describe acids, we describe them as being monoprotic or polyprotic. Monoprotic refers to that particular acid being able to donate only one proton. So hydrochloric acid added with water can only donate one proton to the water. That proton there will move to the water, become H3O positive, and we have Cl-. Similarly with HF, hydrofluoric acid, and nitric acid can only donate one proton to the water atom, well, the water molecule, sorry, to make hydronium ions and chlorine atoms, in this case, or fluorine atoms, or nitrate ions. A polyprotic acid is when you can donate two or more protons. So for example, a diprotic acid can donate two protons, and that will be in usually stages or in steps. Whereas a triprotic acid can donate three protons. And this is an example of a triprotic acid over here. we're looking at phosphoric acid. In the first stage, it donates a proton to water to make this substance here, and this substance goes into the second reaction, and we're donating another proton to water. This substance is in the third reaction there, donating another proton, and eventually we have the phosphate ion. So we have multi-stage donation of protons. We can see as the stages go on, the reaction can be greater, or the greater portion of the reaction is favored reverse. So we have a forward reaction here and a back reaction, and over here we have greater reverse reaction, which is shown by this arrow here. The summary: acids are proton donors, bases are proton acceptors. When an acid donates a proton, it becomes its conjugate base. When a base accepts a proton, it becomes its conjugate acid, because it can donate a proton, whereas the conjugate base can now accept a proton. Acids can donate one or many protons, and we define that as being monoprotic or polyprotic, with poly having two subsets as diprotic and triprotic. This is the success criteria. This is what you should be able to do now. Explain the difference between an acid and a base, and identify the acid-base conjugate pairs. These are the questions I'd like you to complete. Thanks for watching.